Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation, please go to smarturl.it/help ISU actuary. An actuary is studying the prevalence of three health risk factors denoted by A, B, and C within a population of women. For each of the three factors, the probability is 0.1 that a woman in the population has only this risk factor and no more. For any two of the three factors, the probability is 0.12 that she has exactly these two risk factors, but not the other. The probability that a woman has all three risk factors, given that she has A and B, is 1/3. What is the probability that a woman has none of the three risk factors, given that she does not have risk factor A? So let A, B, and C be the events of having the three health risk factors, A, B, and C, respectively. And we have a Venn diagram here, and it summarizes the unconditional probabilities of all mutually exclusive pieces. For example, a probability of A intersection B complement and C complement is 0.10. It's one factor. And probability of A intersection B and not C, so intersection C complement is 0.12. Two factors. And we know that only one factor, that probability is 0.10, and two factors, but not the third one, is 0.12. That's indicated in this graph. S refers to the entire probability space. X is the probability that a woman has all three factors. We don't know that, but we'll try to figure it out. So additionally, we also told that 1/3 is equal to the probability of A intersection B intersection C, given A intersection B. And by definition of a conditional probability, this is equal to probability of A intersection B intersection C divided by probability of A intersection B. But the top is X, by definition of X as we had, and the bottom is X plus 0.12, and from this we can solve for X, and X is equal, because 1/3 is equal to X over X plus 0.12, so we multiply both sides by X plus 0.12, and then from that 2/3 X is 0.04, and X is 0.06. And we are looking for the probability of A union B union C complement, so being outside of the union of the three events, given A complement. By definition of conditional probability, again, that's a probability of A union B union C complement intersection A complement divided by probability of A complement. However, the intersection of those two events that we have in the numerator is only the first one, because it is the smaller of the two, and it's a subset of A complement. The complement of A union B union C is a subset of A complement. So this becomes probability of A union B union C complement divided by probability of A complement, which is 1 minus the probability of A union B union C divided by 1 minus the probability of A. And then to find the probability of A union B union C and the probability of A, we just add up all the mutually exclusive pieces in them, because one of them is X. We didn't know it before, but now we do, and we can just add it up. So this ends up being 1 minus 3 times 0.10, minus 3 times 0.12, minus 0.06. 0.06 is X. And at the bottom is 1 minus 0.10 minus 2 times 0.12, and minus 0.06. I'm saying minus because we eventually are going to subtract every single one of those from 1. That ends up being 0.28 divided by 0.60, which is approximately 0.4667, answer C. Please remember, this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Well, good luck in your studies and good luck on the test.